Welcome to the long-awaited solution video for the Advanced Puzzle Mother's Umbrella, published Friday, April 5th of 2024. And it features a large circle with two internally tangent smaller circles, a green one and a blue one, and they are tangent to the large circle and they are intersecting. From the intersection points there is drawn a line segment towards the outer circle, and there's a common tangent to the smaller circles, and this forms a red triangle, and the question is to prove that the red triangle is isoscalous. And I'm going to use more advanced techniques to show that. But what's important is I will approach it from the other side. So I will first more or less ignore the line segment, and later I will find that segment again, but I will also ignore the triangle. What I'm going to do is I'm going to extend this chord from the two tangency points towards the outer circle. And I'm going to use a lemma which is attributed to Archimedes, which states that this angle, so if this ray actually bisects this angle, so the angle IBH is bisected by the line BF. So this means that F is exactly halfway the arc HI. Yes, because those angles are the same. So those two arcs are the same. I can do that also for the blue circle. So if I do that, then not surprisingly it will end up exactly in the same point, because it must this is the same chord. That line must also pass the midway point. So they both end up in the point F, which is halfway. So if I mark the arcs on the outside of the circle, let's say this has angle A, then we also have A. The two arcs are the same. Yes. So that means that if I take the angle FIH, that over here there must be the angle A, and similarly FHI, also the angle A. Okay, now I will draw this line segment for later use. Now I'm gonna use first of all, let's name this little arc HB. Let's say it has size of B degrees, and now I'm going to find this angle, so BCF. It is the addition of those two arcs, so we have the angle over there A plus B, right? That's one. But now I'm going to use a theorem to, if you have two crossing chords, you can find the angle by adding up the arcs on the opposing side. So that implies that this angle FGI is the addition of arc A over here and the arc B. So there we have A plus B as well. A plus B. So that angle is the same. So we have two equal angles, and here also we have an equal angle, which implies that if I look at the triangle FFGJ, it is similar to FB. And I think it is C, but I will have to, yes. So let's enlarge it a bit. Because they have this, of course, this is a common angle, and they have AB, therefore this angle must also be equal to that angle. So we know that this triangle is similar to that triangle. Yeah. But what does that imply? And that is, it's a matter of algebra. You can show that for yourself. Is that if you take the length FG and multiply it by FB, you will find from this similarity that it is equal to F to J multiplied by FC. Yeah. That's basically just proportions of sides. But if you look at this expression, FG times FB, then that is exactly the expression for the power of the point F with respect to the green circle. You come exactly at this length times this length. So that's the power of F with respect to the green circle. On the other side of the equation, you have Fj times Fc, which is the power of F with respect to the blue circle. So what we have here in this equation is that the power of F with respect to the two circles is the same. So the power of F with respect to green is the same as the power of F with respect to blue, which implies that F lies on the so-called radical axis. And the radical axis is the collection of points with equal power to two circles. And if the two circles are intersecting, you know that the radical axis exactly passes through the intersection points. Yeah, which is obvious because on the intersection points the power is 0. Well, it's that for both circles, so therefore the intersection points must be on the radical axis. But we have just proven that F is also on the radical axis. And now we have again found that line segment which we ignored from the first time. So we now have shown that the point F, which is the midpoint of this arc, is on the radical axis. So now we have actually found that that original red triangle, let's draw it again, that one, which is we have found that the top vertex is exactly the midway point of this arc, and therefore this angle is equal to that angle, and indeed the red triangle is isoscalous. And that completes the proof of the puzzle A Mother's Umbrella.